This presentation looks at the TCP/IP protocol. Transfer of data across the network relies on the principle of packet switching. Packet switching is the process of data being broken up into packets before being sent over the network and then reassembled at the other end. This allows data to be transferred across the network efficiently. Otherwise, large files would clog up the network. Small packets can choose different routes through the network. However, packets can get lost during transfer. Each packet contains an error control bit which allows us to check for errors in the packets to make sure they've not been corrupted in transport, the actual data that we want to send, the source IP address, so that is where the packet has come from, the destination IP address, where we're sending the packet to, and also a packet identification so that the computer knows in what order to reassemble the packets. The TCP/IP stack is made up of 4 layers that pass data between each layer. The 4 layers are the application layer, the transport layer, which is normally TCP or UDP, the network layer, which is normally the Internet Protocol, and finally the data link layer. The application layer contains the protocols related to a particular application such as HTTP, HTTPS, FTP, SMTP, POP3, all these protocols we've looked at in another presentation. The application layer interacts with the user via the appropriate application software, e.g. a web browser or an FTP client. The transport layer establishes the end-to-end connection. When files are sent over the internet, they're broken up into small chunks called packets. When they arrive at the destination computer, they are reassembled back into the original format. It is the role of the transport layer to split the data into packets and pass the data onto the network layer. On the recipient's computer, the transport layer reassembles the packets into the original form. TCP and UDP are the main protocols used in this layer. The packets are numbered by this layer to allow them to be reassembled. The transport layer chooses the port number for the sender and receiver. This diagram shows how a message is broken up into packets. So you can see there the message, and different parts of the message will be in each of the packets. So that's the data part of it, and also the packet is each given an identification. The purpose of the network layer is to add the source and destination IP address and route the packets over the network. At the destination, the network layer strips out the IP addresses. When we send a letter through the mail, it's really important to write the receiver's address on the envelope so that the postal service know where to send and direct the message, the letter to. Sometimes on letters people will also put their own address, the sender's address on it. That's just in case the letter does not get to the destination, so that the postal service know where to return the letter to, so therefore the sender knows that the receiver has not received the letter. The data link layer has a network card and deals with a physical connection and adds the physical addresses of the hardware to the packets that it receives from the network layer. Each interface card has a unique MAC address that is a 12-digit hexadecimal code. Over a network, when we're sending a message from one computer to another, it will go via a whole range of routers. At each router, or each step, the sender and receiver MAC address are removed, and then the sender and receiver MAC address, a new one, is added. The receiver MAC address becomes the sender MAC address at each step. So let's have a look at a single packet here. So at each step, or each hop, or each router, what happens is that the MAC addresses get stripped out and then replaced. So the receiver MAC address then becomes the sender MAC address, and then a new receiver MAC address is added, and then it gets sent across the network to the next router. The router then strips out the MAC addresses again and then replaces the receiver MAC address, which is actually the MAC address of that router, now with the sender MAC address, and then adds a new receiver address to it, and then so on and so on through all the routers until it gets to its destination.